Hello, this is the first of 4 lectures online for today. They're each short recordings, and it's about the functional formulation for a quadratic sequence and some of the other formulations that you might want to cross. So, functional and difference equations for quadratic sequences. So, as we talked about last time in class, a quadratic sequence has a certain difference equation form. So, here it is. So, quadratic sequence has a difference equation form. And it looks like this. It looks like an plus 1 is equal to an plus d naught. If we stopped right there, we'd have an arithmetic sequence, but then it has an nd. And it's worth noting here a bunch of things. First of all, you do need an a0 is something. And what else do you have? Well, this d0, what is that? That is the starting difference, the initial difference. It's the difference between a1 and a0. And then this d, that d is the difference between the differences. And of course, n is the position. Okay, so the question is, what does this thing look like as a functional equation? And, well, let's see here. Yes. Is this recursive? No. Notice, this is not recursive. This is not a recursive description. It's not a recursive difference equation. Why? Well, because n appears in the formula. So this video will show you the recursive formula. So there's another difference equation that describes the same sequence that is recursive. And I'll also show you the functional equation. So let's write them out. So here we go. Here's the functional equation. The functional equation has the following form. It looks like this. Same variables as before. An is, well, that d shows up again. Here it is. And there's this bit in front. So it's the same pieces of information you had before. There is same pieces of information before. You have the d, you have the n's, you have the a naught, and the d naught. So they're all in there, and that's the functional equation. Now, it's worth noting you can write this in a different way. You could rearrange some of these terms. If you expand the n times n minus 1, you could write it this way. This is an equivalent formulation that's useful. And it's useful, will show up useful when you're dealing with, instead of a sequence, actually a curve. So this equivalent formulation is sometimes useful. But you can use either one, whichever one seems to suit you better. And finally, there is a recursive difference equation form. that recursive difference equation form looks like this. It says an plus 1 is equal to something. What is it? Well, it's equal to 2an minus 1 plus d. And in order to make this guy work, sure, you need to have a zeros given, but you also need to have a 1 given too in order to make this guy work. Now, one thing you're probably wondering is, well, where's D0? D0 shows up in the previous guy. Where is it here? D0 is the difference between A1 and A0. So you could, in fact, give any two of these three. So you only need any two of these three equations. In order for this to work. So if you're given A0 and A1 and you're given the recursive difference equation, then you're totally fine. If you're given A0 and D0, you're totally fine then, and you can be given A1 and D0 also. Any of those will do, because then you can find the rest. Okay, so this is the recursive equation form. Now, once you've got all these three forms, it's pretty easy to, just like in the case of the arithmetic sequences, you can switch between them more or less at will. Now, I think it's worthwhile to have a look at an example and take a look at a sequence and see exactly how this plays out. So let me consider a particular sequence. So let's consider the sequence. It's the quadratic sequence starting at 3 with initial difference being 1 and the difference of the differences between consecutive being 2. Let me break out a point here. This difference between consecutive differences. Sometimes we call that a second difference. And I'll explain why that is in a moment. But for the moment, let's just go with what I've written here. Okay, so let's take a look at what this sequence looks like. So it's probably easiest if we go ahead and use, well, which form? Well, they all kind of work. They all kind of work just fine. We could go up here and use the original quadratic sequence. We could use the functional equation. Or we could use the actual recursive formulation. Either one of these works. I think probably the initial form that I gave is probably the easiest to start from because it's sort of the most familiar, but the others do a pretty good job too. So let's go ahead and try it. Let's find out, first of all, what A1 is. So A1 is A1 plus 0. And what does that formula say? It is AN plus D0 plus ND. So it is AN plus D0 plus N times capital D. Okay, so now let's fill in these pieces. A0, that's the starting value. So that's 3. What's D0? D0 is this initial difference. And what is the difference between consecutive terms? Well, that's 2. Okay, putting in all those pieces, let's see, that's 0. This is 0, and so we're left with 4. Okay, what's A2? Well, A2 is 1 plus 1. A1 plus D0 is 1. And let's see, then we've got a 1 times, and what's D? D is 2. Okay, so what's A1? A1 we just found was 4. A3. A3 is A2 plus 1. That's A2 plus 1 plus 2 times 2. Well, that's 7 plus 1 plus 4. And last I checked, that was 12. Okay, so it looks like the sequence goes, well, the starting value is 3, so it goes 3, 4, 7, 12. Okay, well, let's try this out with one of the other formulations too. Let's try it with the functional equation form. Let's have a look at that. What is that going to be? So now let's use the functional. And remember, the sequence A is 3, 4, 7, 12, etc. Remember, that's what it is. 3, 4, 7, 12. Okay. And so let's use our functional equation. Our functional equation is A(n) is d n minus 1 over 2 plus n d naught plus a naught. Okay, so let's put our pieces in that we know. The difference between the second order differences, the difference between the differences, that's 2. And what is the initial difference? The initial difference is 1, and the starting value is 3. Okay, we can simplify this. Look at that, 2 divided by 2. Okay, so we're ready to roll. So now let's try it. So what's A0? A0 is 0 times 0 minus 1 plus 0 plus 3. 0 times 0, that's 0, plus 0, that's 0, plus 3, that's 3. All right, good thus far. Here we go, let's do the next one. What's the next one? 1 times 1 minus 1 plus n times 1. And n is 1 here. Notice this 1 minus 1, that's 0. So this is 4. Looking good. All right, and let's see. 2 minus 1 plus 2 plus 3. Okay, here we've got 2 plus 2 plus 3. 7, looking good. Oops, that's supposed to be 3. Okay, 3 times 3 minus 1 plus 3 plus 3. That is 6 plus 3 plus 3. That's 12. Okay, great. So that works. Oops, that didn't work. Okay. Okay, so now let's try the recursive. So let's see here, the recursive version. Well, let's see here. We need to know what A0 is. A0 we said was 3. And what were we given? We were given D0 is 1. Now remember, D0 is the same thing as A1 minus A0. Well, we know A0 is 3. A1 minus 3. So we can solve for A1. A1 is, if you add 3 to both sides, you'll find it is 4. Check, that looks good. So the next thing we need is the formula. And the formula says what? It says an plus 1 is 2an minus an minus 1 plus 1. What's d? D is the second order difference. That's the 2. Okay. So let's try it now. Okay. And we want to get 3, 4, 7, 12. Here we go. So we want to find A2, and that's A1 plus 1. This is 2 times A1 minus A0 plus 2. A1 is 4, and A0 is 3. So that's 8 minus 3 plus 2. What's 8 minus 3 plus 2? That's 8 minus 1, isn't it? 7. Check. Working out pretty good. Let's try A3. That's A2 plus 1. That's 2a2 minus a1 plus 2. And here we go. 2 times, what's a2? A2 is 7. a1, what's a1? a1 is 4 plus 2. Okay, this is 14 minus 4 plus 2. Okay, what do you know? That's 12. Again, works. Okay. Alrighty, so that is as far as we'll go in this video, and we'll continue in the next video. So, see you there.